Now, with functions, we can add, subtract, multiply, divide. Okay? So, whenever we see the sum, now I'm not going to go through all of this, the sum f plus g, the difference f minus g, the product f times g, and then the quotient f over g. Okay? Well, you're going to be given, let's look at this example here. We're going to call it example A. F of x is equal to 5x plus 8. So you're given two different functions. And we have g of x, which is x minus 4. So this is going to be just a little bit of review. It's asking us to, A, find f plus g. So how we go about doing that? So what you're saying, you're going to add f of x plus g of x. And we're substituting what we call f of x, 5x plus 8, plus what we call g of x, x minus 4. Now we have more than one term, so I would suggest placing parentheses around it, because when we get into the subtraction of it, then subtraction means we're going to have to change the sign of the one that's being the polynomial or the function that's being subtracted. So going back to like terms, drop your parentheses, combine like terms. Five x plus x, 8 minus 4, and then we have here what, 6x plus 4. Now, it's also asking us to determine the domain for each function. What will be the domain of 6x plus 4? Well, think about it. Because, don't you think about it? We're adding. So our solution is 6. If I told you to graph 6x plus 4, it's a linear function. So our domain is from negative infinity to positive infinity. Now, we'll determine as far as, setting something equal to 0, or if it's greater than or equal to 0. Well, when radicals come to play, we'll be using the inequalities. Now, if this were a fraction, at some point there will be a fraction, then we can set the denominator equal to 0. All right, next one, we're going to find f minus g. Okay, f minus g of x, f of x minus g of x. So here we go. We're subtracting 5x plus 8 minus x minus 4. Going back to what we know about polynomials, change the sign of the polynomial that's being subtracted. What's being subtracted here is the x and the minus 4. We're going to drop the parentheses, so bring down the 5x plus 8, and we have negative x and positive 4. Combine like terms, and we have here 4x plus 12. So what is our domain? Here. Well, because we just went over something like that, it'll be the same thing. Yes. Next one, we want to find f times g. Fg of x, you're saying f of x times g of x, so we're going to multiply. We have here 5x plus 8 times x minus 4, where we're going to FOIL. Let's distribute the 5x. We have 5x squared minus 20x, and then we're going to take the 8 and distribute twice. We have 8x minus 32. Adding your like terms, we have here 5x squared minus 12x minus 32. Here again, our domain, which would be, is this a fraction? Think about it. On the very first page of page 53, we talked about a polynomial function without radicals or variables in the denominator. And for this type of function, the domain is all real numbers. So we don't have a denominator. Our domain is negative infinity to positive infinity. And then lastly, we want to find f over g. So we're saying f over g of x, which is equal to f of x over g of x. So we're saying here 5x plus 8 all over x minus 4. Now this is going back to simplifying rational expressions. And if this could be factored, if the numerator could be factored, then we factor it. If the denominator could be factored, we factor. But there's nothing that we can do. And we can't divide x minus 4 into 5x plus 8. But we can state a restriction here for our domain. So all numbers except what? 4. X cannot equal to 4. Therefore, our domain is, help me out, negative infinity, 4, union, 4, positive infinity. There we go. Example 2b, we have here f of x is equal to 3x plus 4 over x squared minus 49, and we have g of x is equal to 2x minus 3 over x squared minus 49. We want to add it, we want to subtract, we want to multiply, we want to divide. I'm going to find one that's a little bit hard here, okay? So we're going to add. So we're saying f of x plus g of x. And that is going to give us, we're saying 3x plus 4 over x squared minus 49. This is going to be a refresher with adding rational fractions here. Plus 2x minus 3 over x squared minus 49. Now, what do we know about, go back to fractions 101. Whenever you have like fractions, meaning the denominators are the same, what are you to do? Add the numerators, right. So we're going to combine the numerators, 3x plus 4 plus 2x minus 3 all over a common denominator. So we don't need to write the x squared minus 49 twice. It says right over a common denominator. Combine like terms. So we have 3x plus 2x. That gives us what, 5x? And then we have 4 minus 3, which gives us 1 all over x squared minus 49. Okay, now if 5x plus 1 could be factored, we will factor it. Okay, x squared minus 49, the denominator, you can factor it or we can keep it as this. We don't have anything to divide it out. Okay, that's in the numerator. Okay, So all we can do here is just really work from, just combine our terms that's in our numerator. But we do want to set a restriction here for our domain. Right, so what we're going to have to do, set your denominator, x squared minus 49 equal to 0. Solve for x. We have x squared is equal to 49. Take the square root to both sides. And we have x is equal to plus or minus 7. Okay? So our domain. We can say x cannot equal to negative 7, or x cannot equal to positive 7. Those are excluded. Okay? So think about your number line. Reading it from left to right. How are we going to set this domain? So I'm going to need your help. What are we going to have here? We know it's going to be union. Uh-huh. Negative 7, 7, yes. And 7 infinity. There we go.
You don't use the bracket whenever it has
The inequality.
yeah, okay.
Yes. Okay. Next one. Subtract. Yeah, I know it's kind of toasty in here today. So we're going to subtract, taking the same questions, same functions, 3x plus 4 over x squared minus 49 minus 2x minus 3 over x squared minus 49. Same thing, the same rule applies when you're adding with like or subtracting with like fractions, denominators are the same, bring your numerators together. 3x minus 4 minus 2x minus 3. I purposely placed parentheses around that 2x minus 3 because when we subtract, we're applying that negative to both the 2x and to the minus 3, not just to the 2x only. Keep your denominator the same, yes. That should be plus.
Yeah, that's what I was wondering.
There you go. Okay. Now, let's distribute the negative. 3x plus 4 minus 2x plus 3 all over x squared minus 49. Combine like terms, 3x minus 2x, which is what x, 4 plus 3, 7, all over x squared minus 49. That should be plus 7. Okay. Let's factor the denominator. That's x, that's the difference of two squares, x plus 7, x minus 7. The x plus 7's divide out. Now our solution is just not x minus 7 because we crossed out the numerator. So in the numerator is 1. So our solution is 1 over x minus 7. So what do you think the domain would be? Because it's not what we simplified it to. Because remember, we have to satisfy everything in the question here. So it's not just what we stick our restriction to as we solve for x minus 7. It's going to be, we have to satisfy everything at this, and going back to, because if we were to go back and check our work, we have to make sure we cover what we have is a plus 7 as well. So our domain is going to be the same as addition.
Should we even take it that far then?
If you're simplifying it, yes, take it that far. when you're simplifying, yes, we do want to take it that far. But when we go back to stating the domain, let's go back to what we have originally that's set, yes. So there's no need for me to go back and rewrite this domain again since we've already defined it for addition. You're going to multiply. Okay. So we're saying here, 3x plus 4 over x squared minus 49 times 2x minus 3 over x squared minus 49. How do you multiply? Let's go back to fractions. Basic rule of fractions. How do you multiply fractions?
Straight across.
Straight across. 3x plus 4 times 2x minus 3. Now let me say this. Even if we factor the denominators, you're going to get x plus 7, x minus 7 twice. Okay? There is nothing that we can cross this out, even if we kept the 3x plus 4, 2x minus 3, there's nothing that we can divide out, no matter what. So as we multiply, it's going to be something big, okay? The denominator. But before we proceed on multiplying, what will be its domain? Same thing. Yes. Just because we're multiplying, our domain is still the same. Still have those same restrictions. Okay? As addition and subtraction. So, we're going to FOIL the numerator. You have here 6x squared minus 9x plus 8x minus 12. And then our denominator, we're going to have here x to the 4th minus 49x squared minus 49x squared plus 2,401. So just for time's sake, just know that I FOILed that. Here's our answer. 6x squared minus x minus 12 all over x to the 4th minus 98x squared plus 2,401. There's no need to factor it because these are the factors right here. And because the factors are right here, there was nothing that we could divide out. Okay? You've done everything that you could do here. You multiplied the numerators, you multiplied the denominators. There's nothing else that you can do, and your restriction as far as your domain is still the same. So when you're in Math Excel and you come across something like this, I don't want you to say, oh, this must be wrong, okay, because I think I got one of these questions from there. Go
I
ahead.
forgot to mention,
Divide. F over g of x is equal to, you're saying f of x divided by g of x. So, you're saying this. 3x plus 4 over x squared minus 49 divided by 2x minus 3 over x squared minus 49. This is what we called a complex fraction. Two ways that this can be done, okay? You can find the LCD, and that's one, or you can rewrite this as 3x plus 4 over x squared minus 49 and use the division symbol. You can rewrite it. That long division sign, you can rewrite it with the division symbol. 2x minus 3 over x squared minus 49. Now, what do we know about dividing of fractions? Right. Multiply by its reciprocal. Keep the first fraction the same. Change your division to multiplication. Flip the second fraction. X squared minus 49 over 2x minus 3. What divides out? And we're left with 3x plus 4 over 2x minus 3. That's what we have as it's simplified. Now, I think I kind of, as I look at this, answered one of the questions from as far as the domain for B. Okay. Now, yes, we're going to, our domain is going to be part of the original question where we had the x squared minus 4, but we also are looking at, and I didn't say that, I just didn't realize it until now, we're also looking at this solution here, our solution 2x minus 3. That's going to be a restriction there as well. Now, the reason why, I just had an aha moment, okay? The reason why we can set this, going back to subtraction where our solution was 1 over x minus 7. Okay, when we set that x minus 7 equal to 0, it gives us 7. That restriction was already there. Okay, even though we included with the x squared minus 49, that we don't need to write 7 comma to infinity. We don't need to write it twice. It's already there, so it's already included with this part here. Now, going back to the division again, yes, our restriction is the same as addition, but we're also going to be looking at our solution here. There is a restriction where we have to set 2x minus 3 equals to 0. Therefore, x is equal to 3 over 2, but 3 over 2 is excluded. Okay, so where is 3 over 2 on the number line? Right. Okay, so remember our other restriction was our domain was x could not equal to -7, or it could not equal to +7. Remember that. So let's think of our number line. I'm going to draw it here. Here is -7. Here is 3 over 2. Here is +7. So we need to set it for each of those. So at -7, reading from left to right, you're saying here, this is our domain, negative infinity, comma, -7, union, -7, comma, what? What is next here? 3 over 2, union, 3 over 2, 7, union, 7, positive infinity. That is crazy.